this is Mr. Ashton going through the January 2003 C1 paper for your exam tomorrow. Okay, so turning over, question 1, so we're expecting that to be on coordinate geometry. So I'm expecting key principles to come up such as gradients, equations, line, etc, etc. So it says that the points A, B have these following coordinates. Now when I write them down, I like to stack them one above the other. It maybe makes working out the gradients slightly easier. And it says the line L has the equation x plus 2y. So we have these different coordinates and we have this line. It says find the equation of AB. So to find the equation of AB, I'm going to use the form y minus y1 equals mx minus x1. M is the gradient of AB. So I need to work out the gradient of AB. So the grad of AB, I always tend to think of that as the difference in y's divided by the difference in x's, which is obviously then your differentiation as well. So it sort of works quite nicely for that. So the difference in y's, minus 3 minus 1, over 2 minus 4. Now in some, minus 3 minus 1, and then 2 minus 4. So that's going to give me minus 4 there, over minus 2, which is positive 2. In some respects, it would have made a bit more sense to me to do minus 1 or 1 minus minus 3 and then 4 take away 2. It's going to get a little bit noisy just because the bell's gone, but try to ignore that. So that's the gradient done. So then to work out the equation of AB is going to be y minus. Now I'm going to use B's coordinates, they're both positive, but I can use either of these to work out the equation of AB, either A's coordinates or B's coordinates. So y minus 1 is equal to 2x minus 4. So then I get y minus 1 is equal to 2x minus 8, and then I'm going to get it all onto one side. I'm going to keep my x coefficient positive, so I'm going to get minus y, and then I'm going to get minus 7. So that minus 1 going over and becoming a plus 1 to go up there. Okay, so it says show that AB and L are perpendicular. Okay, to do that then I want to have it in the form y equals mx plus c. So I'm going to write that in the form y equals mx plus c, which would be 2x minus 7. And then from what they told me before, so that's for AB. For L, I need to rearrange x plus 2y minus 11 equals 0. So that is going to be 2y is equal to minus x plus 11. So y is equal to minus x over 2 plus 11 over 2. Okay, so its gradient here, so that's for L. Grad of L times by the grad of AB should equal minus 1. Now that's if they're perpendicular. If they're not perpendicular, it won't, and it will show me, because it says show that they are perpendicular by here, I'll know pretty quickly if I've messed this up. So the gradient of L1 would be x over 2, so that's going to be minus a half. If there's no number there, the number in front of x is 1. So minus a half times by 2, which would then be minus 1. So there we go, they are perpendicular. Part C, it says the lines AB and L intersect at point C. So basically what's going on, AB is a line like that, L is a line like that, and where they cross we need to find, and that's what they're calling point C. So that's point C, that's AB, and that's L. So to solve where two lines meet, that's how we use simultaneous equations. I'm going to call this equation 1, and I'm going to call this bit here, I'm going to call that equation 2, and I'm going to sub 1 into 2. So wherever I see y, I'm going to change it to 2x minus 7. So here, I can see it's 2y, so I'm going to change that to 2 brackets 2x minus 7, because I've already said that y is equal to 2x minus 7 there. So that is then equal to minus x plus 11. So then 4x minus 14 is equal to minus x plus 11. 5x would equal 25. X is equal to 5. Now I know x equals 5, I will sub x equals 5 in, I'll sub it in 1. So y is equal to 2 lots of x, so 2 lots of 5, which is 10, plus 11. No, it's not, sorry, I've read the wrong bit there, minus 7. So y is equal to 3. So my coordinates for C are 5, 3. Okay, and then finally for part D, it says find the lengths of AB and AC, hence find the value of the constant k such that AB equals KAC. Give your answer in simplest form. Okay, so I'm just going to start a new page for that. Okay, so the coordinates for A were given as 2, minus 3. The coordinates for B were given as 4, 1. And then C I've just worked out is 5, 3. So you can see I'm looking back there, 5, 3. Okay, so if I want to work out the length of AB, the length of AB would be the square root of the difference in y's squared, and then add the difference in x's squared and square root it. So it's basically Pythag. So difference in y, so from minus 3 to 1 is a distance of 4, so 4 squared, plus the differences between 2 and 4, which is a distance of 2, which is root of 16 plus 4, which is root 20, which is root 4 times root 5, which is 2 root 5. Okay, so I'm going to give it in simplest form because it's said in the question to give it in simplest form. And then for AC, we do exactly the same thing. It's the square root of difference in y's. So from A to C, difference between 3 and minus 3 for the y's is 6 because it goes from 3 to minus 3, plus a distance of 3. So that is the square root of 36 plus 9, which is root 45, which is root 9 times root 5, which is 3 root 5. Okay? Now, this bit now says show that AB equals KAC. Okay? I'm stealing that bit from here. Okay? Now, what was AB? AB was 2 root 5, and AC was 3 root 5. Okay? Now, to work out the value of k, I don't know what k is, so I've just left it there. I need to just get k on its own. So I'm going to take this times by 3 root 5 over here to get 2 root 5 over 3 root 5 is equal to k. Root 5 is on the top and bottom. K is equal to 2/3. So I can now say, therefore, AB is equal to 2/3 of AC. Okay. Question 2 is our surds question, so should be pretty good at that. Obviously, during this video, if I were you, I'd be pausing it and trying to beat me to it. You know, pausing it, having a look at the question. Can you beat me to it? Fast forwarding me, I won't be offended. Okay then, and now and again I might stop to have the odd tea break. So 6 root 7 plus 11 root 2. I'm going to start solving this as I go along. So whatever the denominator is, we times by that, but change it to a plus sign. So root 7 plus root 2, all over, and then root 7 minus root 2, and then root 7 plus root 2. Not going to go into the reasons why we do it. You know, it's too close to the exam now. You should know that. If you don't, you should have come and seen me before. 6 root 7 times root 7 would just be 6 times 7. And then this would be plus 6 root 14. And then I'm going to get minus 11 root 14. And then I'm going to get minus 11 times plus root 2. So that's going to give me minus 11 times 2. Okay, I don't know if you can just about see that now. Over. And then that's going to give me root 7 times root 7 is 7. 1 second, there we go. Is root 7. And then I'm going to get plus root 14 minus root 14. That's the whole reason why I've times by this plus version, so these would cancel. And then I get minus 2 there. So it's going to give me 42 plus, no, it's not going to give me plus anything. It's going to be minus 6 minus 11 is minus 11 root 14. And then it's minus 22 there. Over 5, because these two things cancel. 7 minus 2 is 5. Okay, so then the fact that this is 5, I'm suggesting, oh hang on, I've made a mistake here. 6 take away 11, that's minus 5. Okay, I would have thought that 5 will go into what this final thing is, and that's how I just spotted I accidentally wrote down 11 there, because I knew 5 didn't go into it. 42 take away 22 is 20, minus 5 root 14. Divided by 5 becomes 4 minus root 14. Okay, and then for part B, you can probably just about see it by here, we've got 3 over 2 root 6. Now, to get rid of the denominator, we're just going to times top and bottom by root 6. So that's still the same fraction. And then it's going to be plus, and I'm not going to write that as root 6 over 2 cubed. I'm going to write it as brackets root 6 times root 6 times root 6 over, and then it's going to be 2 times 2 times 2, and then it's not cubed anymore. So I get 3 root 6 up on the top here. I'm going to get 2 root 6 times root 6 would be 2 times 6, and then it's going to be plus root 6 times root 6 is 6, times by root 6 again is 6 root 6, over 8, This is then 3 root 6 over 12 plus 6 root 6 over 8. And then to actually add those together, I need to have the same denominator. So they both go into 24. So 2 numbers over 24. I've doubled that, so that would be 6 root 6 over 24. And then I've tripled that, so this would be 18 root 6 over 24, which is actually going to work out to being 24 root 6 over 24. So the final answer is root 6. Okay. So far through to question 3. So we've done questions 1 and 2 so far. Number 3. Okay, so they put something in bold. I can see that without even really reading the question. It says the curve has that equation for its x coordinate, so x is equal to 3. If you know x, you need to know y. It doesn't tell us. We'll have to go and work that out by subbing that x coordinate into that. Find the equation of the tangent. We like the tangent. That's the easy bit. If it was 6 marks, it would say the normal there, but tangent's really, really easy. Okay, so y is equal to 3x squared minus 14x plus 13. So I'm now subbing in. I'm going to say when x equals 3, y is equal to 3 squared minus 14 lots of 3 plus 13. That comes to 27 minus 42 plus 13. If I get together the two positives, I get 40 minus 42, which is minus 2. So y is equal to minus 2. So my coordinates of the curve where you've got this tangent would be 3 minus 2. I now need to know its gradient because I'm going to use the formula y minus y1 equals mx mx minus x1 there. Okay, so dy by dx, that is going to be 6x minus 14. I'm then going to say when x equals 3, dy by dx is equal to 6 lots of 3 minus 14, which is 18 minus 14, which is 4. Okay, which you can put in brackets and call that m. So then I'm going to sub that into this information here. Y minus y1, so y minus minus 2 would be y plus 2, is equal to 4 brackets x minus 3. I'm then going to get y plus 2 is equal to 4x minus 12. I'm then going to get I'm going to write it in the form y equals mx plus c because I can. And I get y equals 4x minus 14. That is the gradient of the tangent there. Whenever you differentiate, you find the gradient of the tangent. If I wanted to know the normal, if I was asked the normal, we're not going to bother doing all of it, but the normal would have to be minus a quarter, because minus a quarter times 4 times is to minus 1. Then I do exactly the same thing here, but instead of using 4, I just use minus a quarter. Okay, so that's 3 done. So now let's do 4a. So 4a says, express this question in the form a plus x plus a squared, blah, blah, blah. Basically, can you complete the square on this? So first bit is going to be x squared plus 8x plus 5. I'm then going to halve the b coefficient and square the lot. That would then give me x squared plus 8x, but a plus 16. So I need to get rid of that 16, but I also have this plus 5 still there. And then finally, I'm going to get x plus 4 squared, and then I'm going to get minus 11 there. Okay, so I've done what it wanted me to do for the first part. It then says use your answers from part 1 to find the least value of this thing here. Okay, so the way I do this, I say x squared plus 8x plus 5 equals, and then I write down the thing they've asked me to do here, which is 3x squared. 3x squared plus 24 plus 15. 24x plus 15. I wish I'd left a bit more room, but I'll have to squeeze it in there, sorry. Now that clearly isn't true. That clearly isn't equal to that. So I'm trying to look for some sort of similarities, and I see there that the x has been made to 3. So I've tripled that. Triple that is 24, and then triple that is 15. So this is very easy. I just need to times this side by 3. Okay? Now, for this to be true, all I need to do is change this version here for my completed the square version that I just worked out. So that is going to be 3 brackets, x plus 4 squared minus 11. And then I just expand the bracket to 3x plus 4 squared minus 33. Therefore, its least value is x equals minus 4, because that's what makes this bracket 0. If that was 0, 3 times 0 is 0, but leaves a minus 33. So the y is whatever's left, okay? But that will always, if that's 0, it doesn't matter what that number is. It will always be that just gets times by 0, which is nothing. And the y will always be whatever's left by here, okay? So that is the least coordinate. Well, this is the least coordinate. This is the way you'd write it. Okay, and if you wanted to, you could check that on Desmos and actually draw that graph on the app Desmos. Okay, so that's for A and B. So we've now done 4 questions. So now let's do question 5. Okay, and so 5A. So 5A says, for which values of blah 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 of quadratic equation 2 distinct real roots. Okay, so you should know from this that we're using b squared minus 4ac, something to do with 0. It'll either be less than 0, equal to 0, or greater than 0. In this case, it is greater than 0 because it has 2 distinct real roots. If it said something about 2 equal roots or 2 repeated roots or just equal or repeated roots, it would have been equal 0. And if it had no real roots, it would have been less than 0. In this case, with 2 real roots, it's greater than 0. I'm now going to write down A equals, B equals, and C equals. So I'm getting that information from here. We treat that as a quadratic equation, which would be ax squared plus bx plus c. So A is equal to 5, B is equal to 6, and C is equal to minus 3k. So now I'm going to do 6 squared minus 4a, and then C being minus 3k. And then I'm going to say that's greater than 0. So that becomes 36. I'm then going to get minus 4 times by 5 times by minus 3, so it's going to be a plus by there. 4 times 5 is 20, times by 3 is 60. 60k there is greater than 0. And then I think I'm almost done actually. So I'm going to take the 36 over, and it's going to become minus 36, and then k would be minus 36 divided by 60, so k is greater than certainly 6 over 10, minus 6 over 10. K is greater than minus 3/5. Okay, and then for the next one it says solve this inequality, blah 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 is less than or equal to 0. Okay, now this is the one that as a class we've been struggling with. We've really got to get our heads around this. We can't lose these marks tomorrow, they're too easy to lose. Okay, so we've got 2x squared, we've got minus 11x plus 15 is less than or equal to 0. So I'm going to times together the a and the c coefficient to get 30. They add together to make minus 11. What pair of numbers times to 30 but adds to minus 11? And I know it's minus 6 and minus 5. And then I'm going to do 2x, so I drop just the squared and put in minus 6. And 2x minus 5 is less than or equal to 0. And then I get x minus 3. And I keep it as 2x is less than or equal to 0. Now this statement here isn't strictly true, but the way the method that we looked is that we kept on doing that, but you must cancel down any brackets that you can cancel down. So my two solutions are x equals 3 and x equals 5 over 2, which is 2.5 if you want to think like that. But that wasn't asking me that. It was saying where it's less than or equal to 0. So if we visualize that as a parabola, so a U-shaped graph, it crosses in 2 distinct places because I've got 2 solutions. So I draw just the x-axis, I don't bother drawing the y-axis. I know this would be 2.5 and I know this would be 3. I'm interested in where it is less than or equal to 0. Okay, and it is less than or equal to 0 between these 2 values here. So that is 1 going to the other. So I'd say x is greater than or equal to 2.5 or x is less than or equal to 3. Now what I can do with this inequality in particular is I can switch it to being 2.5 is less than or equal to x. Now this one was already x is less than or equal to 3, so what I'm going to do now is physically pick that up and plonk the x's on top of each other, so it reads 2.5 is less than or equal to x, which is less than or equal to 3. If it is less than or equal to 0, you write it as one inequality, but if it wanted greater than or equal to 0, that would have been above the graph. That would have been this bit here and this bit here, which would have been 2 disjointed regions, and you would have had 2 separate inequalities. Okay, question 6. Okay, the differentiation from first principles I am going to skip. We've done loads of those in class. You should know how to do those now. For your second bit, when it says differentiate 5x to the power of 4/3 minus 9 over x, I need to write that. I always write y equals as just sort of like just a bit of a hangover of just I'm used to seeing it like that. You won't lose a mark for writing it like that. 5x to the power of 4/3 minus 9. Now I don't want to have that as over root x. I want to bring that up, so it's going to have a minus power. So x to the minus, and then the square rooting is like halving. Okay, so the differentiate with respect to x just means times by their powers, reduce the powers by 1. Means I'm going to get 5 times by 4/3 x, and then reduce this by 1 will become 1/3. Minus, and then I'm going to say 9 times by minus a half, and then I'm going to get x to the minus 3/2. Okay, now I'm going to make that a little bit nicer. 5 times 4 is 20/3. X to the third, I'm going to leave it as just x to the third. You could write that as cube root of x if you wanted to. Minus times by a minus by there is going to give me a plus answer here, and that is going to be 9/2 x to the minus 3/2, and that is fine for your full marks there. Okay then, question 7, so binomial expansion. Now, things that I'm noticing before I've even started the question, I'm given the power, so that means I'm going to use Pascal's triangle. If I wasn't given the power, I'd have to use what's in the formula booklet, but that's not the case here. So I've got a plus 4x to the power of 6. Pascal's triangle, I know this line here, 1, 4, 6, 4, 1. At least I hope I know it. I think the other one was above it's 1, 3, 3, 1. Yeah, that's right. And then 1, 2, 1, yeah. Okay, so I'm just going to skip to the 6th row now. So 1, 5, 10, 10, 5, 1. And then 1, 6, 15, 20, 15, 6, and 1. So this is the row I want because the second number is 6 and the power was 6. Okay. Now, it wants me, what's it say? It says, in the binomial expansion, the coefficient of the term in x squared is twice the term in the coefficient of x. Find the value of a. So I don't need to do the entire expansion here. I only need to go up to x squared because that's my highest power of x. So that is going to be a to the power of 6. Okay, really, actually, I'm going to put my coefficients in. It's going to be 1, a to the power of 6, and then 4x to the power of 0. Plus, so the next one now, be your coefficient of 6. We would reduce the power of a by 1 to a to the power of 5, and then 4x to the power of 1. And then plus 15, a to the power of 4, and then 4x squared. Plus, I just say dot, dot, dot. There's no need for me to do that because it just asked me to work out the value of a. It didn't ask me to do the full expansion. Okay, so I'm now going to work out this bit here. 4x to the power of 0 is 1. 1 times anything is just 1. So this first bit is just a to the power of 6. Plus, that is going to be 6 times by 4. 6 times by 4 is 24, a to the power of 5x. And then this one here, now this is where you've got to be super careful here. This isn't 15 times 4, it's 15 times 4 squared. 4 squared is 16. 15 times 16, no idea. By all means, pause the video and have a go at working it out. I know 15 times 15 is 225, so then 15 times 16 must be 15 more. So that is going to be 240 because 225 add 15 is 240, and then it'll be a to the power of 4 x squared. This is the coefficient of x. This is the coefficient of x squared. Okay, I should say coef there as well. Now, I'm starting to read the question here and doing what it says. It says coefficient of term of x squared. So that is this 240 a to the power of 4. That thing is means equals. Equals twice, so 2 lots of the coefficient in terms of x. So twice 2 lots of a to the power of 5. Okay? Now, the first thing we do is we are going to expand the bracket to get 48 a to the power of 5. I'm now going to bring everything all on, so that's a to the power of, I've messed something up here. What if I messed up? No, that is a to the power of 5. No, that's fine. I'm now going to bring absolutely everything onto one side because I've got a's on both sides. It'd be wrong to divide through by a to the power of 4 here. Okay, so the reason why is that it would discount one of my answers. So that's why we always just bring everything onto one side and then we'll factorise. That's how we like to solve things with where you've got things in both of them. So minus 48 a to the power of 5. Right then, the biggest number that goes into both of these, I reckon it's 24 because I know 24 goes into that and it quite clearly goes into that. If needs be, I'll factorise again after that. So 24, smallest power of a would come outside, so that'd be a to the power of 4 there, and that's going to be 10 minus 2a. Now that means I can pull out another factor because they're both even. I can double this to 48a to the power of 4 and get 5 minus a by there equal to 0. So I've got two solutions that would work here. So the solutions are a to the power of 4 is equal to 0, therefore a is equal to 0, or because this is timesing this, 5 minus a would be equal to 0, so 5 would be equal to a. So I believe the answer is 5. Okay then, question 8. So question 8 says, given that x plus 2 is a factor of the following thing, write down an equation satisfied by p, hence show that p is equal to 9. If you can't get anywhere with this, make sure that you carry on with the next bit, because they've then told you what the answer is, so you can do that, okay? Now, if x plus 2 is a factor, that means we sub in f of minus 2, okay? So sub in f of minus 2 into that would give me px squared. So that is going to be p minus 2, not squared, sorry, cubed. And then it's going to be plus 18 brackets minus 2 squared, minus 4 times by minus 2 and minus 8. And I can put that equal to 0 because it told me it was a factor. If it had a remainder, I would have had to put in whatever the remainder was. This is going to be minus 8p. This is going to be plus 4. Plus 4 times 18, double of 18 is 36, double of that is 72. Minus 4 times by minus 2 is plus 8, and then I need to take away 8. They cancel out, leaving me with 72 is equal to positive 8p. 72 divided by 8 equals p, so 9 is equal to p as required. Okay? Okay then. So the next bit says solve the equation. Now if you look at this thing here, this thing is that. So we don't need to find a factor because we already know that this thing is a factor. So I'm going to say 9x cubed plus 18x squared minus 4x minus 8. I know that x plus 2 is a factor. So I'm going to, or I need to be putting equal to 0 to that just because it says equals to 0 there. Okay, so once I've factorised, I need to actually find what x equals. To make 9x cubed, I've already got the x squared. This must be 9x squared there. So 9x squared times by x would give me 9x cubed. I need to also make minus 8 there. I've got plus 2, so this must be minus 4 by here. It has to be, because 2 times by minus 4 is the only way of making minus 8. I'm going to make 18x squared there. I know this will have some form of x there. I'm going to make x squared by doing 2 times by 9x squared, and that will give me plus 18x squared. Now that's already given it. Altogether I am supposed to get 18x squared, so I don't need to add on anything at all there, so that means it must be plus 0x. So in some respects I don't even need to write it. And at first you might look at that and think, oh, how am I going to factorise that? But you should notice these are both square numbers, which is really good. So that's given me a big confidence boost now that I've got the right answer. This is the difference of two squares. So you square root that and get 3x, and you plus the square root of that, 2. And then you also get 3x and 2, but this time with a minus, hence the name, the difference of two squares. And that should have been something you've seen at GCSE, but we haven't seen it for a while at A level. So then x is equal to minus 2, x is equal to 2/3, and x is equal to minus 2/3. Okay, although I've sort of done them the opposite way around to what they are, it doesn't matter. They were my solutions. Question 9. We have a quadratic here. So we have our minimum point as being 1 minus 2 and our roots through the x-axes as minus 5 and 7. It says, can you draw y equals 3f of x? So for that first graph there, you're expecting, because it's outside, you're expecting it to do what you think to the y coordinates. So the y coordinates being 0, 0 and minus 2, I'm going to triple those. Triple of 0 is 0, triple of 0 is 0, but triple of minus 2 is minus 6. So what that'll do is it'll sort of elongate the graph, going through exactly the same coordinates as it did before on the x-axis, minus 5 and 7, 0. But this new minimum point will be 1, minus 6. Okay, so that's part A. And then for part B, it says f of minus x in a bracket. Now I can tell you that if you get a minus involved, it will be a reflection. And the way that I always remember this is I draw the graph of y equals x squared. I know that the graph of y equals minus x squared is upside down. Now that has been reflected in the x-axis. But if I was to draw the graph of minus x squared, what would that look like? Well, I'd hope you'd realise that if you did minus 3 squared, it would just give you 9, which is what the answer is when you stick in minus 3 anyway. So that is just a reflection there. So when the minus is inside the bracket like we have there, it is a reflection in the y-axis. But if it was outside of the bracket, it would be a reflection in the x-axis. So all I need to do is reflect this graph in the y-axis. So the 7 and the 5, or the minus 5, will switch places and turn to their opposite signs, and this will become a -1, -2. So drawing that, something like that instead, and it will be -1, -2. This will be -7, 0, and this will be 5, 0. Okay, and final question. Yeah, nothing on the back, which is good news. Final question. I'm going to start a new page for this. Okay, question 10. So I've got this curve. I'm going to write out the curve straight away. So y equals x cubed minus 3x squared minus 9x plus 14. So it says find the coordinates and the natures of the stationary points. Stationary points is when the gradient is 0, so I need to differentiate that, put it equal to 0, probably factorise a quadratic, I would have thought. So I'm going to get dy by dx is equal to 3x squared minus 6x minus 9. I will now put that equal to 0, which is 3x squared minus 6x minus 9. Okay, now I can spot there that there is a multiple of 3 going on here. So rather than doing a really complicated quadratic, I'm going to divide everything by 3. 0 divided by 3 is 0. 3 divided by 3 is 1x squared, or just x squared, minus 2x minus 3. I'm then going to factorise to get x minus 3 and x plus 1. So x is equal to 3, or x is equal to minus 1. Now I have those values, I need to find out what the y coordinate is. So I'm going to say when x equals 3, y equals, so it is going to be x cubed, so 3 cubed, minus 3 lots of 3 squared, minus 9 lots of 3, plus 14. That's going to be 27 minus 27 minus 27 plus 14. 27 minus 27 cancels. Minus 27 plus 14 would be minus 13, I believe. Just going to check I've done that right. I feel confident with that, but you never know. You get an answer like that now and again, you think, well, it's quite big, but no, I think that's fine. So 3 minus 13 is my one set of coordinates, and when x is equal to minus 1, we get y equals minus 1 cubed, important to put that in a bracket, minus 3 lots of minus 1 squared, minus 9 minus 1, plus 14. Minus 1 cubed will be minus 1. Minus 1 squared will be plus 1, but then you will times it by minus 3, which will give me minus 3. Minus 9 times minus 1 will give me plus 9. And then plus 14 plonked on the end will be plus 14. Put the positives together, we get 9 add 14 is 23. Take away 3 is 20, take away 1 is 19. Now, I would be tempted to go and plot these coordinates here just so we've got some idea of what the graph looks like for when I do my nature of points. So there's my x and y axes, which you can now see. I'm now going to plot the points 3 minus 13, which would be somewhere around there, 3 minus 13, and minus 1, 19, which is around here, minus 1, 19. So for me, it's pretty obvious what the min and what the max are already. I'm assuming this to be the maximum point because it's higher up the y-axis than that one is. I'm assuming this one to be the minimum point. Also, when I draw that, because, well, let's actually do the double differentiation before that. If it doesn't prove that, though, I've done something wrong, which is more of a worry. So dy by dx, so d2y by dx squared to do the double differentiation and find the nature of the points. You've got to be very, very, very careful here. In terms of what we're doing, we've got dy by dx here. Not this bit where I divided by 3. I've got to use what dy by dx was, and then I just differentiate that. So that's going to be 6x minus 6. So 6x minus 6. And I'm going to state by here, when x equals 3, d2y by dx squared would equal 6 lots of 3 minus 6, which is, what's that, 18 minus 6, which is 12, which is greater than 0. Therefore, it is you'd assume a maximum, but it actually means it's a minimum. And that's what I'd said already by there. That's what I assumed. And when x is equal to minus 1, d2y by dx squared would equal 6 lots of minus 1 minus 6, which is minus 12, which is less than 0, so you'd assume that is a minimum, but it's actually the other way around. It is a maximum. That's exactly what I thought, okay? So now I'm going to sketch that graph maximum, so it's doing a little peak there and then a little trough there at minimum. Now, before I draw that line to try and join them up, I need to go back and look at the question here. It goes through plus 14, so it's got to go through plus 14 on my axes there, so I've drawn that not very well so far. And then I need to mark it goes through 14 there. Then it shoots up to positive infinity, and here it shoots down to negative infinity. Final question I'm asked is... Final question I'm asked, so sketch C, I've done that. It says, given that this equation, this thing here, which is this thing here, equals k, has one real root. Get your pen, put it horizontal to the axes. Now, where has it got one real root? Well, it has one real root here, 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 here. Now it has 2. As soon as it crossed that point here, now it's on 3, 3, 3, 3, 3, 3, 3, 3, 3. Now back to 2, and now 1, 1, 1, 1, 1. So it has one real root when it is above this value, and it has one real root when it is below that value. So when k is greater than, and we're above 19, that's the value we're looking at there. So k is greater than 19, but also k is less than minus 13. And they are two different arrows. They're not pointing each other, those two arrows. One's going up that way, one's going down that way. So these will be two totally separate inequalities. So for part C, it says find the range of possible values for k. K is less than minus 13, or k is greater than 19 would be your solutions there. If it said 3 real roots, then I would have been interested in this section here with my pen, which would have been k less than 19 and k more than minus 13, and then you could have had 2 arrows pointing at each other because I was interested in between here and here, which would have been one long continuous inequality. But that is all of the paper done. I hope that was useful. Good luck for your exam tomorrow. I will be in from 7 o'clock. Good luck.